Okay, let's have a look now at a really cool section, which is the financial maths part. I like this section because obviously it's part of everything around us, and it's very applicable to, and you can use it on a continuous basis. It's real, it's tangible. We all look at interest rates, we see it, it's mentioned on the news, etc. So let's have a look at financial maths. Now, what have we got in this section, right? Financial maths, as it says, financial maths. Okay, what is financial maths all about? It's about, let us say, the value of money and the fact that money changes its value as we go. Obviously, you get today, a year from now, 2 years, 5 years. And how does a bank or a financial institution make money? It makes money by selling money. It borrows money at a low rate and charges you at a higher rate. That's how a bank makes its money. They sell money to you, and it's called interest, right? Now, essentially, we're talking about the time value of money. One of the most important things in this is actually drawing a timeline. Okay, I know in some textbooks it comes a bit after we've done some work on it, but the timeline is kind of an important concept. So let's just have a look at it. Timeline. Now onto my timeline, I put this as now, okay, and I put this as the future, and these are my time periods. Right? This is how many, what are we looking at? Are we looking at a years, 2 years, 5 years? Are we looking at 60 months? What are we talking about in terms of time periods over there? Then this is called the P, which is the principal. Okay? This is the amount invested or spent now. Okay, and the amount is over here, is the value in time periods. The value in n time periods, right? So let us say this is, shall we change color just for a change? This is now is called 0, 1, 2, 3, 4. So this is 5, let's say 5 years, okay? And we have got a formula that links all of this lot together. And what do we say? I is the interest rate, and simple interest, there we go. We've got formula 1, which is simple interest, where we say that the amount, the future amount, is the principal, the current amount, times 1 plus I times n. I is the interest rate, okay? And 2 is the compound interest. Okay? It's compound interest. I is the interest rate. Okay? The interest rate is usually given as a percent per annum, and we'll get into compounded monthly whatever shortly. Okay? And it's an interest rate. In the formula, we use it as a decimal. Okay? In other words, 7% is actually 0.07. We divide it by 100 to get it to the decimal. And that looks a little bit like a 2. 7. Okay? So, when we start this process, we say to ourselves, okay, I like to start by drawing a diagram. I put down what have I been given, generally speaking, over the period of time, and I normally put my I in here, so many percent per annum. So I put everything on my little diagram because that works well for me. It puts, once again, like we did in previous ones, like in analytical geometry and functions, we put the stuff on the diagram. Those of you, as I've said before, who do physics, you'll know that's a recipe I like. I put everything onto the diagram because it shows me I can forget about what's written in the text then. Okay? I don't have to remember or ask myself, have I got this? Have I got that? It's right in front of me. Okay. Now, what do we mean by simple interest and compound interest? Okay. Well, simple interest, essentially, if we can break it into a diagram, okay, we start with it now, and at the end of the period, okay, we get a little bit of interest over there, right? Let's say this is 2,000 and this is 2,000. We get a little bit of interest over there, okay? Then in simple interest, what happens is this. The next piece, the interest is worked out on this amount here again, all right? So essentially, you're not getting interest on interest, whereas if we take it and we say, okay, let us take put in that in a currency unit. I'm using ZAR, 2,000 over here. Now we go to the end of the period, same story, right? Now, the compound interest says, okay, there's my little bit of interest, but I will give you, can you see? Interest on the interest. Okay? I think it was Einstein who said it's the most powerful force. One of the most powerful forces in the universe is the compounding effect of money. Right? But now we've heard the term, all right? Let us look at this word, and many textbooks use the term decay. Okay? What if we have it going the other way? Okay? What if R, it's not R, R, whoops, come here. What if R is less than, if R is negative, okay? If R is negative, what do we mean by that? Well, it means that effectively we start there and the value decreases over the period of time. Well, those of you who do accountancy, you know that that's called depreciation, right? Okay, another word is a decay rate. Depreciation rate and a decay rate. Because in maths, okay, and this is financial, we're linking it to money, but in maths we also cater for decay rates, the rate at which radioactive substances decay, the whole concept of the half-life, etc., etc. That's quite an important thing. The rate at which a bacteria grows, the rate at which it decays. Those would be the rates of absorption of a chemical, for example. So we've got to cater for different tastes, different disciplines, really. So we use the term decay rate, okay? Decay rate. Now, if you're aware of the depreciation situation, if I buy a car today, all right, that depreciates in value, it goes down in value. I am not going to get the same value. So if we've got then, let's say A, we can have simple decay, all right, simple decay, where amount is equal to P times 1 minus I to the N, and compound decay, where A is equal to P times 1 minus I, whoops, a little bit too quick for my own good, 1 minus I to the power of N. Okay, so we've got all that. Compound interest, I didn't put the formula in here, I thought not. Okay, and we say A is equal to 1 plus I to the power of N times P, right? So now we're at this concept of decay rate, simple decay, compound. It's exactly the same as a process where the value increases. It's just that we decrease it. Now there's two concepts that we have to look over here. Okay, simple decay is also called straight line depreciation. Okay? And compound is called reducing balance. Depreciation. Okay, so we've got straight line depreciation, and the compound is reducing balance depreciation. Well, that's actually the terminology that we use in accountancy, isn't it? Now, if you actually went and plot these, all right, you get something that looks like this. Okay, this is, for example, this is time, and this would be the value in whatever currency you chose. Could be dollars or whatever the case might be. And if it's a straight line, it goes down like so, depreciates over time to a zero. Whoops, that zero is the other side, really. Okay, it has no value at a certain period of time. Okay, that's its value today, and it depreciates to nothing. That is the straight line method, right? This is straight line depreciation. The next one is that we can have the reducing balance for the first period, and then it starts to do this. Okay, this is our reducing balance. Okay, for the first time period, it's identical. Thereafter, it's going to change, right? Now, what do we use this for? Well, temperature versus time, right? How quickly a cup of tea cools down. Okay, right? So let's just have a look at the graph. There you are. Temperature versus time. Depreciation of currency or an asset. Population of bacteria, animals dying out. Okay, rates of extinction, etc., etc. So very often we're using it in different contexts than money. I think most of the focus is going to be on money, but you can never be too sure. What are the key trigger words? Is they say straight line, reducing balance. That automatically tells you that it's either simple or it's compound. Reducing balance is going to be the compound decay. Okay, compound decay. And the red line, the straight line depreciation, is simple decay. Right, now basically what are the hints that I can give you for this? All you do is you put a timeline, okay? Put your now, and we're going to do some examples just now. Put your now, put in the future, etc. And put in the, all right, if it's 25 years, that's a bit long. But split it into segments maybe of 5, so it's, then you put in what you're given. Am I given the principal, the amount, the interest, the compound rate, the period, the simple rate? What am I being given? And look for the one that you don't know. Okay? Right, compound interest. Now let's look at this, because this section gets a little bit, how can I put it? It gets a little bit sort of weird if you don't sort of follow what's going on here. And it's not too tough, because we say that we get, for example, 8% per annum compounded annually. Okay? So what does that mean? That means we say, okay, at the end of, this is now, okay, this is at the end of year 1, all right, we add the interest. So if we have 1,000 Rand over there, all right, I am going to add interest at the end of year 1, okay, and I'm going to say that you are then going to be, let's have a look. Well, first of all, we said amount is equal to P1 plus I to the power of N, which is going to be equal to 1,000 times 1 plus I is equal to 8% per annum, all right, plus 0.08 to the power of 1, right? And that gives us, let's have a look, okay, mode 1. That gives us 1,000 times 1.08 all to the power of 1, which is 1.1000. Whoops. Okay. Sorry, I got a syntax error there. 1000 times 1.08, which is going to be 1080. So basically, there's 1,000 Rand, and the bank comes and it adds the 80 on top to give us a balance in our account. Always think of this as an account, all right? It could be your own money tin, all right? But think of it as the bank, rather. The money is in the bank, it's earning the interest. So at the end of the period, the bank says, right, you've got 1,000 Rand, you've had that for the whole year, therefore I will give you 8%, 1080. Then the bank says, right, for the second time period then, okay, they will then give us 8% on top of that. Okay, so they will use that interest and give us the 8%. So how would we work it out? We would say to ourselves the following. We would say amount is equal to 1,000 times 1.08 to the power of 2. Because n is equal to 2, isn't it? It's 2 years, 2 periods, but 2 years per annum. I want to make a linkage here between per annum is years and n is years in this case, right? So it's 1.08, 1,000 times 1.08 all to the power of 2 is that, times 1,000 equals that, and it's 1166, okay? 1166.4, okay? And that balance there is 1166.40, okay? 0.40, exactly, yep. All right. Remember, it's money, so we always go to 2 decimals. And now, so how much interest have we got? We've got 166 Rand 40 interest, right? So there's interest of 166 Rands and 40 cents, and the original amount was 1,000 Rand, and it stays in the bank, and so forth, okay? Now, that happens there. Now, but sometimes we get, it changes. This 8% changes. We get the following term, okay? And the term is as follows. Semi-annually, I'm just going to write down the terms first, all right? Semi-annually, quarterly, monthly, and obviously you do get daily as well. But let's just look at this. Let's get the principle in our mind, or the concept first. That's the term, and this is now, I'm going to make a note here. This is interest added at the end of every there, okay? Right, this is every half year, i.e. 6 months. This is therefore twice a year, 2 times per year. Quarterly, every quarter year, i.e. every 3 months, which is then how many times a year? 4 times per year, right? And monthly, right, okay, every month, which is monthly, which is 12 times per year. In other words, what are we saying? Remember we said previously, let's just think about it. We said here's now and here's the end of the year. Remember in the previous example, I added the interest there and then I worked it for the next period. If we're now adding it semi-annually, it means at the end of 6 months, I add a bit of interest and then I carry on. So we have to adjust for this kind of different values or different way of adding interest, don't we? We can't just use the same formula. It's not going to work. We have to change our interest, the way we work out our interest. Now, essentially, what am I going to do here? All right. I'm going to look at this process. I'm going to take 1,000 Rand now. All right. Let me just bring this back down. All right. Remember, now I can actually move on to this page now. All right. Let's have a look here. I'm going to say this is now. And let us say that we've got 1,000 Rand. Right. And over here, I'm going to say this is in. Here's my timeline. This is I equals 12% per annum, okay, compounded annually. That means that I get my interest added at the end. So therefore, I can say straight away, the amount is equal to P times 1 plus I to the N, which is 1,000 times 1 plus 0.12 to the power of 1. Okay? That should be straightforward because that is going to give us 1120. Okay? But now I'm going to change it. Okay? I'm going to move it and I'm going to say, all right, we've still got our 1,000 Rand. This is now. But what I'm going to do is I'm going to add interest over here and again over here. So this is going to be semi-annually. What will they tell me? They will tell me the interest rate is 12% per annum compounded semi-annually, which means twice every year. So what do I have to do? It means that I'm getting 1.06 here and 1.06, 6%, 6%. I divided my percentage by 2 to allow me to work in the increments. Therefore, I can say, there's my first part, there's my second part. Essentially, therefore, I say that A is equal to P 1 plus I divided by N to the power of N. Let's examine what I'm saying. But first I want to finish it off. 1,000, 1 plus my interest rate was 0.12 divided by 2 and 2. N, remember, N is the number of time periods. And we have got 2. There's 1 and there's the second one. We are adding interest twice, aren't we? Therefore, I have to say in the first part is 6, in the second part is 6. So look at this here, and this is where I want to draw your attention. This here and this must agree with each other. Now I'm going to compound it every quarter. Therefore, let's just do the drawing so that we can see what we're talking about, right? And we're going to do there, 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 and there. So I'm going to add interest. Can you see here? I've now got how many compound periods? 1, 2, 3, 4. So N is going to be equal to 4. So I have to adjust my interest rate formula, and I therefore say that the amount is equal to, I'll work them out in a sec, is equal to 1,000 times 1 plus I is 0.12, right? Divided by, in this case, 4, all to the power of 4. And the number that I get over there is 1125.51. Whoops, that's Sorry, sometimes it's not only my writing, but sometimes the tablet is a little bit slippery. Oops, doesn't help if you 5.51 over there. And this one over here comes out to be 1123.6. Okay, like that. Can you see that it's getting bigger? Nextly, I'm going to do it nextly. That was a ridiculous word, wasn't it? But hey, you know what? Whatever counts. The next one I'm going to do, we're going to do it monthly, right? I am going to move this up, and then I'm going to do this monthly now, right? Which means there we go. Now, how many of these have I got? I've got every month. Okay, 1, 2, 3, 4, 5. I can actually open them up a little bit, but I don't have to draw each one. I think you get 1, 2, 3, 4, 5, 6, right? So n in this case, n is equal to 12 compounding periods. Therefore, my amount that I get is 1,001 plus my interest is 0.12 over 12, all to the power of 12, and that's going to be equal to 1126.83. 1126.83, right? This is what we call the nominal and the effective rate, all right? Now that we've looked at the concept, the nominal rate okay, is actually equal to, let us say, the 12%. That's the nominal rate, isn't it? Okay, this is the quoted rate. Right? That's the quoted rate. That's what you're given usually, all right? The effective rate. The effective rate, okay, is going to be 1 plus I effective is equal to 1 plus I nominal over m to the power of n. Okay, like so. And n is number of compounding periods. Okay. Essentially, let's take an example. Okay. Example here. Example number 1. An interest rate is quoted at 8% per annum and compounded quarterly. Compounded quarterly. Okay? Therefore, I say to myself, therefore, I is equal to, wait, let's just see. And they ask us, calculate the effective rate. All right, let's just put down here and calculate I effective. Okay, it's going to be bigger, isn't it? So let's see. We say, right, in how many periods are we compounding this? Is equal to 4. Okay, 4 compounds. Therefore, I say, right, 1 plus I effective, just a seckie, get rid of you. 1 plus I effective is equal to 1 plus I nominal is 0.08 divided by 4, all to the power of 4. Right, let's see what we did. This was the quoted rate. Quoted rate, the nominal rate. Okay, I divided it by the number of compound periods and then multiplied it or put it to the power of the same number. Therefore, 1 plus I effective is going to be 1.0824. Like so. Thus, my I effective is 1 minus that, 0.0824, which is 8.24%. Okay. Let's have a look at one more example here. Example, it's the same, let's say, quoted at 8% compound, 8% per annum compounded, okay, monthly. Therefore, n is going to be equal to 12. There's 12 times we're going to add interest. Therefore, 1, I keep writing I, don't I? 1 plus I effective is going to be equal to 1 plus I nominal, which is 0.08 over 12 to the power of 12. That's going to be 1.083. Okay, and therefore I effective is 8.3%. That's what you're actually getting, okay? Next section I'm going to do, we're going to be applying these to some examples, okay? Just in finality, just look and say, how many time periods are we compounding it by, right? And that is what you divide your nominal rate, your quoted rate by, and then you must match it on top, okay? I'm going to move forward with it and use it in quite a few examples now, okay? So, hope you had a good one with that one. As I say, it can be a little bit sort of like, but just give it a little while and play with this a little bit like we're going to do in the next one. We're going to do, I think, quite a few examples that I've got. Okay, cheers. I'll see you in the next one. Bye.